In this video, I'm just going to briefly explain what we should be doing in this interactive lab. First of all, you guys should click on the link on my Canvas page, which will take you to this interactive where you can change a couple different things down here. You can have it be an explosion, an elastic collision, or an elastic collision. You can change the mass, you can change their initial velocities, etc. First, I'm going to kind of show you guys, though, the worksheet that you guys should be filling out and accompanying that. Should look something like this. In each scenario, it will tell you collision 1 and then explain a little bit that's different about each of them. All right, so collision 2 here, and then the third page we start elastic collision, so make sure for the first two you have them as inelastic. Okay, but what I want you guys to do is, in this case, it's going to have the blue car at rest and the red car has some velocity. So we fill out the velocity up here in this area I'm circling with my mouse. Then you fill out the mass of the red car. Please think about the fact that the mass of the red car is going to stay the same before and after. Same with the mass of the blue car. And then afterwards you only have one velocity because they're stuck together, right? Hence it being called an inelastic. They don't bounce apart. So once you have that, it should be fairly easy to fill out this chart, okay, where you have to put the mass of the object, its velocity, and then figure out how much momentum it has. Right? So for the red cart, let's say hypothetically I have it at 1 kilograms. Let's say I have it at 1 meters per second, or 1 for its velocity. So its momentum then that I would fill out, wrong tab, I would fill out 1 here, 1, and then in the chart I'd say 1 kilogram times 1 meter per second equals 1 momentum. Okay. Let's say my blue cart at the beginning is not 0 kilograms, sorry, it's 0 meters per second. It has some mass, doesn't matter what it is. I could put it at 2, but it doesn't matter because the momentum of the blue cart at the end is 0. So the total system, 1 plus 0, you should get your total system momentum of 1. Okay. Now what they're asking for here, this little triangle momentum, is they're asking you how much the momentum changed. So if my momentum of the red cart before is 1, and let's say hypothetically it goes down to 0.5, that means my change in momentum for the red cart would be negative 0.5. Okay, and then you do the same thing for the blue cart. You calculate the momentum of each spot, and then you see how much does it go up, how much does it go down, right? Let's say that the momentum before was 0 of the blue cart, and the momentum after the collision was hypothetically 2. Then it would be a positive 2 as your change in momentum, right? In this final category, this final column, your change in momentum of the red and blue carts should add up to the change in momentum of the system, right? Which, if we remember, the conservation of momentum means the momentum should be the same before and after, so this final column should be 0. It might not be exactly 0, but it should be pretty darn close to 0. Okay, so you guys are going to do this again by coming to your interactive. I said I wanted it as an inelastic collision, so I'm going to click that, and then I'm going to start the interactive, right? Moving super slow. This is probably a terrible idea. Start them here. 1 meter per second, 1 meter per second, 1 meter per second, and then it hits, and now they're at 0.5 meters per second, right? And so I would record my masses, record the velocities of those objects, and then record the velocity at the beginning. Okay, I hope that helps. Please let me know if you guys have any questions as you go through it, though. Have a good one, guys.